Hello, students. We're going to talk about solving equations with variables on both sides. So what is an equation with variables on both sides? Well, you have 2x plus 1 is the same as 3x minus 5. So it's an equation, it has an equal sign, and there's x's on this side and there's x's on this side. So the variable is on both sides. What are we trying to do? We're trying to solve it. We're trying to find the value of the variable that makes the equation true. I want to know what number can I put here and here that's going to make 2x plus 1 the same as 3x minus 5. So here's a more complicated example, and we're going to take it step by step. The first thing we're going to do, this is given to us, the first thing we're going to do is distribute. So we have on this side 2 groups of 5x minus 1. So it's going to be 2 groups of 5x minus 1, which we can distribute. We can think about it as 2 times 5x and 2 times negative 1. 5x, 2 times negative 1. That's going to be 10x and negative 2. At the same time, we can distribute on the other side. So we can do distributive property on this side too. So this one is going to be 3 groups of x plus 11. That's going to give us 3 x's and 3 11s. That's going to be 3x plus 33. All right, who remembers what to do now? We have variables on both sides. Okay, it's a little bit more complicated. So all we did there was simplify. I could straight up think I've got 10 on this side and 3 on this side. The key here is to focus in on the x's. We have a choice. We can take away 10x from each side, or we can take away 3x from each side. I'm going to take away 3x on both sides. Why am I doing that? That creates a 0 pair. You see the 0 pair? What's 3x and negative 3x put together? That's 0. That's a really good idea, because now when I simplify this, I have 33 right here, which means I don't have any more variables on this side. How about this side? Remember, combine like terms, we're going to put this 10x with this negative 3x, and that's going to be 7x minus 2. Would you look at that? I distributed, I used the subtraction property of equality, and I used the identity property. I got a 0 plus a number is that number, and now I've turned this big mess into a 2-step equation of x multiplied by 7 and subtracted by 2. So now I've been practicing solving 2 steps. Now I can just continue from there. So I'm going to do 7x minus 2 plus 2 is the same as 33 plus 2. Do the same thing on both sides. There's my 0 pair. And I have 7 times some number is 35. It's getting simpler and simpler as I do properties on both sides. And then I divide both sides by 7, and x is 5. The value of the variable that makes the equation true is 5. So if I put a 5 in here and a 5 in here, hopefully both sides are going to be the same. Let's check it. So I'm going to check it. I'm going to do 5 times 5. I'm going to do 2 times 5 times 5 minus 1. That's going to be 2 times 24, which is going to be 48. Okay, so if I put a 5 in here, this side is 48. How about the other side? I'm going to check the other side too. I'm going to do 3 times 5 plus 11. Okay, 5 and 11 is 16. What's 3 times 16? 48. See, if I put the 5 on this side, it's 48. And if I put the 5 in right here, it's 48. That means I know I got the right answer. I found the value of the variable that makes the equation true, makes both sides the same. Let's try another one. This one also has some distributive property in it. I am going to start by distributing. There's other ways to do this problem, but I'm going to start by distributing and taking the opposite of the stuff in the parentheses. So remember, there's kind of like a -1 in front of here. So I'm going to focus in on this part, and I'm going to multiply -1 times 5, which gives me -5. And I'm going to do -1 times -r, which is going to give me +r. Ooh, very cool. All right. Now I have variables on both sides. There's two things you could do here. You could just straight up take 2r off of both sides because they match, but I'm going to combine like terms. So I'm going to do 3r minus 5 is the same as 13 plus 2r. Combine like terms. All right, now I have variables on both sides. I've got 3r's over here and 2r's over here. I'm going to subtract these 2r's from both sides. Subtract 2r there, and I'm going to subtract 2r here. It's going to be in my 0 pair. That's the whole reason for doing that, is because I knew it would go away. If 3r minus 2r is 1r minus 5. And now we have a one-step or a two-step equation. Yay! I'm going to add 5 on both sides. And there's my 0 pair. I'm just going to write r. 13, 14, 15, 17, 18. 18. R is 18. Okay, I'm going to do a more formal check for this one because I have more room. I'm going to do 2r minus 5 minus r. Is that the same amount as 13 plus 2r? Okay, and we found out that r is 18, so I'm going to put an 18 where I see the r's. I'm going to work this side first. 2 times 18 is 36. And this is going to be, 5 minus 18. It's going to be negative 13. Okay, and then I have 36. Negative times a negative is a positive. Subtraction is addition of the opposite. So this is going to be 49. This side, when r is 18, is worth 49. Let's see if this is also 49. So I'm going to do 13 plus 2 times 18. 2 times 18 is 36. Look at that. 13 and 36 is 49. Okay. Both sides are 49. I found the value of the variable that makes the equation true. What about this one? This is a special case. Can you think of a number that would make this true? What about x equals 3? Is 3 plus 1 the same as 3 plus 1? 4 equals 4. So x equals 3 is an answer to this question. Is this the only answer? Can you think of another number that I could put for x? How about x is, let's try a negative. How about -7? If I put a -7 in here, is that going to be true? Am I going to have something that's true? Can you have more than one answer for the same problem? -7 and -7. -7 and 1 is -6. -7 and 1 is -6. What is happening here? How about pi? Put pi in there. What's pi plus 1? Is that equal to pi plus 1? 3.14159 plus 1 is 4.14159. What if I subtract pi on both sides? This is fun. That's 0, that's 0, that's 0. Does 1 equal 1? Interesting. That's an identity. That also works. Okay, so this is a type of problem where the answer, the way you would write the answer, there's two ways to write the answer. You could say, there are an infinite number of solutions. It's one way to talk about this type of problem. The other way that you can talk about this problem is you can tell me what the answers are. X is all real numbers. It can be any number that you think of can be an answer to this problem. Because the problem itself is an identity. Saying x plus 1 is the same as x plus 1 is saying it doesn't matter what x is, you're going to have the same thing. This is my favorite answer. This is a more math answer because you're telling me what the answers are. It's any real number. Okay, how about this one? Any answers that would make this equation true? Any values for x that would make it true? Let's test x equals 3. If I do 3 plus 1, is that ever going to equal 3 plus 2? Is 4 ever going to be the same as 5? False. Not going to happen. Not true. So what does that mean? Let's try another answer. Let's try x is -7. -7 and 1, is that going to be the same as -7 plus 2? No, that's not going to work. Okay, so this is a type of equation that has no answers. No answers. No real answers. No imaginary answers, no answers. So we say no solution. That's the best answer for that one. All right, that's the lesson for today. Let's see. Where's the algebra? Variables on both sides of an equation can be confusing. The key is that you do the same thing on both sides to get the variables together. Remember, in math, we can push through and persevere on our challenges. Do your work, be good, bye.